Hello. So right now I am getting ready to solve or derive the Laplacian and polar coordinates. Right here in this sheet, I just have all of the partial derivatives already solved out so that I can just plug everything into it and easily derive. So first off, I'm going to start off with URR. So the derivative of URR is one moment. This marker seems to have died. All right, the derivative of URR is UXR times XR plus UXXRR plus UYR YR plus UYYRR. And then we have 1 over R of UR, which is that UXXR plus UYYR. Then we have 1 over R squared of U theta theta, which is practically the same thing as URR, UX theta plus UX theta plus UY theta Y theta plus UY Y theta theta. Okay, let me see if I can another marker. This one is significantly better. All right, so now of this, I have the equation for the derivative with derivative of with respect to x with respect to r, which is uxx xr plus uxy yr. So I'm just going to substitute that in for this right here. So I will have uxx plus, or wait, no, uxx times xr plus uxy yr times xr plus uxxrr plus, and then I also have the equation for this, which is uyx xr plus uyy yr yr. Okay, and then yes, we just have uyyrr. And so now the 1 over r or actually, here, I'll just go ahead and multiply out the 1 over r. So I have xr ux over r plus uy yr over r plus ux theta then I have the 1 over r squared of u x theta, which similarly over there, I have the equation for the derivative, which u x theta is equal to u xx times x theta plus u xy y theta. So I can just substitute that in real quick. X theta plus u xy y theta times x theta and plus u x theta plus, and then I'm going to have to come down here, it looks like, and then I have here, you can't really see that, it's u y theta plus y theta, okay, which will be xr plus theta plus y theta times y theta, I believe, yes. Derivative with respect to y theta, and u y theta. All right, so at this point, I pretty much have all of the, I believe I have everything, all the different, actually no, I don't. I have so I've subbed in this the equation for this derivative and of the derivative with respect to x and r, and then the derivative with respect to y and r over here, and then I subbed in the derivative with respect to x and theta, and the derivative with respect to the derivative with respect to y and theta. So now I am able to sub in lots of other fun things. I believe I have everything right now. Yes, perfect. Okay, so now I can start subbing in right here the derivative of x with respect to r and x with respect to theta and so on and so forth. So where did I put my marker? Here we are. So, or actually, first what I'll do is I'm going to multiply everything out by its all of these out by yr here and xr here. So here we'll have, draw a line to separate this. Here we will have u x xr squared plus u x y yr xr plus u x xrr plus u y x xr yr plus u y y yr squared plus plus u y r plus u x xr over r plus u y r over r plus, and now it's going to be a little complicated, but I'm going to multiply like this x theta out to this and the y theta over here out to this, while also multiplying out the 1 over r squared, just to speed things up. So here I will have u x theta squared over r squared plus u x y theta x theta over r squared plus u x theta over r squared plus, I can probably fit 1 in over here, u y x x theta y theta over r squared plus u y theta squared over r squared plus u y theta over r squared. Perfect. So now that everything is multiplied out, I can start substituting in the derivative of x with respect to r and so on and so forth. So first off, we have u xx times the derivative of x with respect to r squared. So that will be here. I will also draw another little line to divide. So now you'll have u xx times the cosine of theta squared plus u xy, uxy times cosine of theta times sine of theta. Perfect. And then right here we have u x times the derivative with respect to r, which is 0 actually. So this will cancel out, so I'm just going to go ahead and erase that to make things a little cleaner. Then right here we have u y x x r y r, so that will be the same thing as this right here. So it'll be equivalent to this, so we can just put 2 in front of there. And then we have u y times y, the derivative of y with respect to r squared, or I suppose that makes it a little bit more clear, which will be uyy times sine of theta squared. Then we have uyr, which is actually also equal to 0, because right here, y of r, so y is equal to r sine of theta, and then if we take the derivative of this with respect to r, we're left with sine of theta, and then take the derivative with respect to r again. There are no r variables in this, so it's equal to 0. All right, then we have the derivative with respect to x times the derivative with respect to r. So that will just be u of x times cosine of theta over r plus u of y times sine of theta over r plus, and then we have uxx with times the derivative of x with respect to theta, which is equal to negative r sine of theta over r squared, or all that's squared. So then, and well, since this is squared, it's really negative r squared times, so it's the derivative with respect to x twice times negative r squared times the sine of theta squared. So we can really just take this out right here, and boom, squared, squared. Okay, and then here we have u with respect to the derivative with respect to x with respect to y times the derivative of y with respect to theta times the derivative of x with respect to theta. So there we will have u xy times r cosine of theta times negative r sine of theta all over r squared. Yes. And just going back and double checking everything. Okay, yes, I believe everything is correct. Okay, then we have the derivative with respect to x times the derivative of x with respect to theta, which is equal to negative r cosine of theta over r squared plus u of x y times negative r sine theta times r cosine theta all over r squared. Now I'm at the end over there. Okay, perfect. So now I'm over here at u, the derivative with respect to y, y times the derivative of y with respect to theta squared, which will be equal to plus u, y, y times, so this will be r squared cosine of theta squared over r squared plus u, y theta theta over r squared. Oh, wait, whoops. Accidentally forgot to sub that one in, so that's negative r sine of theta. Perfect. So now that I'm at this point, it's really just a matter of, sorry, let me make sure it's still filming. Perfect. My headphones just died, so I'm gonna have to speak up a little bit more now. Okay, so now at this point, it's just a matter of simplifying, really. So let's see. Right here, we have r squared, those cancel out. And then we have here, I can just do, boom. We have that cancels out, so this is minus. Probably not the best way to work right there. Perfect. All right, so then we have these cancel out, and then this turns into a subtraction sign. Similar thing over here, those cancel out. This turns into a subtraction sign, and then also, again, these cancel out. This turns into a subtraction sign, and then these cancel out. Also, this cancels out over here. So now we're left with this equation, and I can just, right here, just erase all of these as to just clean stuff up a little bit. All right, perfect. So now, once again, like I said, just a matter of simplifying. So right here, first, where can I start off with? So I have a 2, okay, this isn't as clear that it's a 2. So 2 times the derivative of derivative with respect to y, with respect to x and y, times cosine theta, sine theta. And then if I come over here, I have 1 negative derivative with respect to x and y times cosine theta, sine theta. And then I have another one right here as well. So these, apologize, my marker is dying on me again. So I have these. And they all cancel out with one another. Perfect. And so then I have some other stuff that can cancel out. Okay, so I have u x okay, I believe I messed up somewhere. y of theta. Oh, there should still be an r there. Oops. And there should still be an r there. Yes, okay, yeah. Whoops, I accidentally erased too many r's. So then I have this over here. I have the derivative with respect to x times cosine theta over r with subtraction sign in front of it. And then over here, I have the same thing, but with an addition sign in front of it. So here. Okay, so I have this and this, which can cancel out with one another. And then I have uy, oh, put the r back in the wrong place. So then I have the derivative with respect to I times sine of theta over r with a subtraction symbol in front of it. And then over here I have positive derivative with respect to I, or y times sine of theta over r. So this and this cancel out with one another. So at this point, I'm going to transfer everything over to this side of the board that I have left so that it can look a slight bit cleaner. Okay, that one works. So now, here, let me rearrange the camera. I think this should work. Okay, so now I'm left with that's not going to work. Apologize. Get some new markers in the physics lounge. Okay, so we have uxx times cosine squared of theta plus uyy sine squared theta plus, or minus rather, minus uxx sine squared theta plus, oh wait, no, I believe, no, this is supposed to be a plus sign, plus y cosine of theta squared, and then if I just rearrange it a little bit, I can have uxx cosine squared of theta plus uxx sine of theta squared plus uyy sine theta squared plus uyy cosine of theta squared. Then over here, I can take out, have it so it's cosine squared of theta plus sine squared of theta plus uyy times sine of theta squared plus cosine of theta squared. Okay. Time to see it. Okay, it seems to be working a little bit better. Oh, or not. Ah, perfect. X. And as we have the equation of cosine theta squared plus sine of theta squared is equal to 1. So this is equal to 1. This is equal to 1, meaning we are left with uxx plus uyy. And there you have it. And so I don't know if I gave a super good look at my sheet that I was using. So right here, I just have x equals r cosine of theta, y equals r sine of theta. And then I just have all of the equations for the different derivatives. So the derivative with respect to r, with respect to theta, the derivative with respect with rr, theta theta, xr, x theta, yr, y theta. And then down here, I have the derivative of x with respect to r, x with respect to rr, yr, yrr, x theta theta, y theta theta. Then I also have the sine of theta squared plus cosine of theta squared equals 1. And for one final look, just in case nothing was super clear because of the markers, I will give a final look at my work.